In this lesson, we focus on NBT, National Benchmark Test, notes and practice for quantitative section of AQL. Right, we recap on the methods of operations on whole numbers. Okay, no. All right. A method for adding. Okay, the network just went. Nobody doesn't go, but it just went, It was strange to me. I was wondering what was happening. But yeah, the network just went and then obviously is restored now. Right now, there's a method for adding, so we shall recap very quickly. If you have 687, you actually adding to 45. You add 5 and 7, you get 2, you get 1, and you bring up the 1 here so that you obviously add the 2. You have a 9 plus 4, and that gives you 13. Bring down 3 and you get 1. And now, if you have the 1 there and you add the 1 up, and you would have actually 6 and the 1 that gives you 7, right? And you have 700s that way. Okay, obviously this is all primary school addition. Right now, the notion of subtraction, where you're taking away 23 minus 5. So if you're saying from 23 you subtract 5, you then get exactly 18. So now if you then say at this pointer you have 23 and you take 1, 2, 3, 4, 5 steps, you actually able to get to 18 straight away. Okay, right. My apologies for the network. Now subtraction is difference between numbers. For example, 104 minus 99. We find the difference between 99 and 104. It takes how many steps to get from 99 to 104? So in other words, the difference. Right. So if you have 99, 1, 2, 3, 4, 5, it takes 5 steps, and we say that this number had to be 5 there. Okay, we're just having a recap on the method of subtraction. Right, a method for subtracting. Right, if you have 734 minus 45, you have the following. So if you have 4 minus 5, you're actually able to see that 4 minus 5 is actually equal to a minus 1. So you take 110 from the tens column. So in other words, you'd have to obviously take 110 from the tens column, having a 2 in the end there in the place of the 3. So now you actually are able to then have a 14, and the 14 minus 5 gives us a 9. 2. Now, when you have the 2 there, you actually able to see that 2 minus 4 is minus 2. And then you need to borrow again because you're getting a negative. So now, in the same way, so if you borrow, for instance, now you've borrowed from this end, you need to borrow 100. If you borrow 100, you bring it to this side here, and you have then this was like a 2 in the tens, so like a 20, and you have therefore obviously like 100, 120 or so. Right, so in other words, you have 12 tens. So you have 12 tens if you borrowed 100. You have 12 tens. And now you subtract 4 from that, and you get 8 tens. 8 tens. You borrowed 100. You borrowed 100. So you're left with 600. But now 600 minus no hundreds would give you 6. 6. Okay, now obviously this is sort of the method you need to learn. Okay. Yeah, but it's all primary school stuff in the AQL. So yeah, but we're trying to familiarize ourselves. I've noted the time that the network had gone. Okay, it was beyond my control. I don't know what happened. I was just talking, and then boom, the network went. Okay, now if you look at this, a method for multiplying. For example, if you're multiplying 13 and 54, right? We saw that 54 is the same as 50 plus 4, so we can be able to write 13 by 50, but also 13 by 4, and then add them up. Put the numbers under each other in the tens and units columns. So in the end, we are looking at 13 times 54. How to multiply that? No calculators are allowed. So you then say 3 by 4 gives us a 12. You put the 2 here and you carry 1. in the units column. Right. And then if you have exactly that, so what then are you able to achieve here? Right, let us check. So yeah, you put 2 in the units column and carry 1 to the tens column, and you have exactly that. Right. Moreover, what then do you have again? So you have the 12 there, and you have the 1 that sits up there. Right. So if you have that precisely, you continue with the multiplication. Obviously, you have exactly your 0 there. So now, moreover, after that, what else do you have? If you have the 4 by 3, and also you actually therefore can continue and do and perform the multiplication. 4 by 1 or 1 by 4, and add 1 to get 5. Right, so obviously you have 4 and 1, you actually multiply those, and you add 1, you get your 5 there. Right, and you continue moreover, so you put your 0 there, and put your 0 in the units column, then just multiply by 5. You have 5, so just multiply by 5. You have 5 by 3, that gives you 15. So in each case, if you get the 15, you put 5, then you actually carry 1 in the tens, right, in the tens column. And therefore, obviously, you have 5 by 1, which gives 5. And plus 1, you get actually exactly a 6 there. You perform the addition, 2 and 0 added together. You get exactly a 2. You add the 5 and the 5, you get a 10, so you bring down 0 and you get 1, and then 1 plus 6 gives you exactly a 7. So that gives 702. Right, so yeah, it's one way to just multiply. I know you learned this in primary. They're just reminding you so that you can be in a position to do these things in the assessments. Right, so now division. We can think of division in 2 ways. Now, A, division as making groups. Okay, now you can deal with groups. 1, 2, 3, 4 groups. 12 sweets. Put them into pockets with 3 in each pocket. How many pockets are there? Okay. Okay, we shall actually look at that. Division as equal sharing. 12 sweets equally being between, right. Share 12 sweets equally between 3 friends. How many sweets will each friend get? All right, so yeah, and we're able to see that now we have 1, 2, 3 friends, and we have the 12 sweets, and we divide the 12 sweets by 3 friends, and we are able to see that obviously you have 4 of those. In the same way here, you have 12 sweets, you put them into 3, yeah, put them into packets with 3 in each packet. How many packets are there? Right, 3 in each packet, so yeah, you actually have the 4 packets. Okay, now a method for dividing, a worked example. Calculate 192 divided by 3. We want to know how many 3's are there in 192. Right, so yeah, if we have 192 and we divide this by 3, we want to know how many 3's are in 192. So there are no 3's in 1, but there are 6 3's in 19. Yes. With 1, 10 remainder. 1 10 remainder. 1 10 remainder. Okay, so yeah, this is the method of division. Our friend, long division method. Right, so now we come here. That was step 1. Step 2, add the remainder of 110 to the units column to get 12. Step 3, there are 4 3's in 12 with no remainder. Okay, so we good. Right, okay, very interesting technique of division. Let's just recap on this method of dividing, but I know very well that this one you can do with ease. So it is the same as the long division you even do in high school. So you have 192, you divide by 3. Right, so if you divide, as said in step 1, there are no 3's in 1, so want to divide 1 by 3, but there are no 3's in 1, but there are 6 3's in 19. So since we wish to say 1 divided by 3, it doesn't happen. So we say 19 divided by 3, you have 6 this way. Right, and if you have 6 this way, we've already learned much ourselves. So we know that 3 by 6, for instance, would give 18. You balance. And if you subtract the 19 and the 8, you get a 1, 2. You divide 12 by 3, you have a 4. 3 by 4, it's another 12, and the result becomes 0. And obviously that gives us exactly that much there. Right, so it's something you need to take note of. That obviously at this point we divided the 19 by 3 and you got 6. But there was a remainder 1, and here's the remainder 1. The remainder 1 therefore makes, add the remainder 1, 10 to the units column. So if add 1, 10 to 2, you get like a 12. And then now you have 12, you divide by 3, you get a 4, and that becomes exactly, so that's a very powerful shortcut. We move forward. Yeah, just take note of this. Okay, we are going to go to the tests soon. I'm just going through the examples, right? For example, approximation. It is useful to estimate the answer to a calculation before doing the calculation. Worked examples. Estimate the answer to, yeah, let's do estimates. 48 by 103. Round off 48 to 50. And 103 to 100. And then you multiply 50 by 100. Multiplying 50 by 100 is the same as multiplying 5 by 1. And then you have 1, 2, 3 zeros. So 50 by 100 gives us like 5,000. So 48 times 103 will be close to 5,000. So we can give an estimate and say 48 by 103, if we multiply 50 by 100, because 48 is close to 50, but also 103 is close to 100. The answer is close to 5,000. It's just an estimate anyway. So the 5,000 is not the actual answer. Now approximate the answer to, if you're doing 25116 and you divide it by 483, it's approximately what? Okay, so in the same way, to estimate, this is like 25,116. We can just say 25,000. We divide by the 483 to the nearest 100 is actually close to 500. So that we can divide this exactly. So if we divide this 25,000 by 500, the 2 zeros cancel out. 250, you divide by 5. The 5 divides 25, giving us a 5, but there's a single 0. So that indeed it is true that, 25,000 divided by 500 is only 50. So we expect a calculated answer close to 50. Yeah, so the answer is going to be close to 50. These are just approximations. Yeah, but clever ways to really say what must the answer be close to. Why is this necessary? Okay, because there's no time. The time is too short. And you need to be like quick. What is the answer close to? So you work with the closest possible answers. Sometimes when you're under pressure, the calculator is not there. And yeah. Right, let's move on. Now, it's very important to deal with fractions. Right, it's important to deal with fractions. That is okay. That is all right. Never mind that. So it is possible to deal with fractions. How do we therefore deal with fractions? Right now, fractions themselves remain very, very important. How fractions work. Now, numerator, which is the top number, and denominator is the bottom number. So 3 divided by 4 has a numerator and denominator. We good. Now we're then saying 3 divided by 4. So now out of 4, we shade 3. 3 pieces of the whole are shaded. 3 pieces are shaded. There are 4 pieces in the whole altogether. So they're like 1, 2, 3, 4 pieces. So 3 out of 4, or 3 divided by 4 of the whole is shaded. Okay, but this is very, very powerful. So it's 3 divided by 4 shaded. If you say 3 divided by 4, it's like you're shading 3 blocks out of the 4 blocks altogether. So just fractions. Okay, let's continue. There are things we call equivalent fractions before we do the tests. Equivalent fractions have the same values, so they're equal to each other. For example, examples: 3 divided by 4. 3 divided by 4 is the same as what? If you multiply 3 by 2, you get a 6. Multiply 2 by 4, you get 8. Simultaneously, you can multiply 3 by 3 and get a 9. But if you multiply the top by 3, you get a 9. 3 by 3, you get a 9. You multiply 4 by 3, you get a 12. We're good. Okay, let's look at the example A. So now we have 1/4 here, and in the 1/4, what are we actually able to see precisely? So obviously, remember that we are dealing with 3/4. So dealing with 3/4, we have this one is 1/4. So, but this is 1, 2, 3/4, and this obviously will be the 4th/4. So if it is 3/4, then you have 1, 2, 3/4 shaded. These become equivalent fractions. Equivalent fractions. What about if it is 6 out of 8 now? Now, 6 out of 8 would mean that if then you look at 8 parts, 1, 2, 3, 4, 5, 6, 7, 8, and you only shade 6 of the parts. 1, 2, 3, 4, 5, 6. There we go. Now, 1 out of 12. Okay. Out of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you're going to shade only 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You shaded 9 out of 12. And where each section it's 1 out of 12. This is 1 out of 12, 1 out of 12, 1 out of 12. But they are 9 of the shaded parts. We can take equivalent fractions by multiplying or dividing the numerator and denominator by the same number. Okay, now equivalent fractions can be obtained by multiplying the numerator and denominator by the same number. So if you have 2 divided by 3, you multiply 2 by 5, you multiply 3 by 5. 2 by 5 is 10, 3 by 5 is 15. Let us deal with equivalent fractions right now. And you have exactly 8 out of 10. We can decide to say, okay, we're going to divide 8 by 2, simultaneously divide 10 by 2. If you do, okay, you divide the numerator by the same number, denominator by the same number, and you get 8 divided by 2. It's actually exactly 4. You divide 10 by 2, you get a 5. Okay, move on. So it's 4 to 5. And these fractions are equivalent. Okay, we go on. Okay, there are certain things we call the improper fractions and mixed fractions. An improper fraction has a numerator that is larger than the denominator, so they're improper fractions. Improper, right? So this one is improper. Improper means that you have 7 to 4, the numerator is bigger. It's 7/4. So in other words, 7 to 4 is like 7/4, because if it's 1 to 4 is 1/4. So these are 7/4. So there are 7/4 pieces. There are 7 1/4 pieces. So now we have 1/4, 1/4, 1/4, 1/4, 1/4. 1/4, 1/4, 1/4. So there are 7 1/4 pieces. Now there's something we call therefore. Okay, so for example, in the 7 1/4 fractions, okay, 7 1/4 pieces. 1, 2, 3, 4, 5, 6, 7. Okay, because this is like 4 squares, and then you have only 1 square left. Because the 4, all of them, 4 plus 4 is 8 squares, you have 1 left. So yeah, it's 7/4. But now there's a mixed number. What is a mixed number? Right, it's made up of a whole number and a fraction, e.g. like 1 3/4. 1 3/4 is 1 3/4. There's 1 whole and 3 1/4 pieces. Okay, let's check. In other words, if you're dealing with 7 out of 4, a mixed number would be 4 goes how many times into 7? It goes once, the remainder is 3 out of 4, and this becomes a mixed number. We move forward. There are certain things we call the worked examples. Worked examples. Write 7/4 as a mixed number. Write 7/4 as a mixed number. So now 7/4, 4 goes how many times into 7? It goes once, so remainder 3/4. Okay. We go on. So 7 divided by 4 is 1 whole. 4 goes into 7 one time, with 3/4 left over. With 3/4 left over. Write 3 and 1/5 as an improper fraction. Let's check this one out. So if you write 3 and 1/5 as an improper fraction, so to do this, therefore, is the same as saying 3 times 5/5 plus 1/5. And this is the same as what? It's exactly the same as 16/5. Okay? All right, all right. Now, this is very, very interesting, this. So in other words, if you have 3 and 1/5, a couple of ways to do that. So it's 3 times, because it's out of 5 here, you multiply by 5/5, but you also add 1/5. 3 by 5 is what? 3 by 5 is 15 plus 1, 16/5. Okay, yeah, in the same way that you can say 3 by 5, 3 by 5, 3 by 5 is 15 plus 1, 16/5. So in which case, it's 16/5 either way, an improper fraction. Adding and subtracting fractions. Okay, we are here. Adding and subtracting fractions. If fractions have the same denominator, it is easy to add or subtract them. Okay, let us deal with the fractions, for instance, like 3/4 together with 2/7. Right, so dealing with this, what are we able to achieve here? The denominators are the same, so we have 3 plus 2, which is 5/7. Adding and subtracting fractions with different denominators. Okay, if the denominator is the same, you add the tops, 3 and 2, and get a 5, and you divide by 7. Work to example 1. Calculate 2/9 and 5/12. Multiples of 9, multiples of 12. Okay, so in other words, we want to find the LCD. We remember all that. Right, so the multiples of 9 are 9. You add 9, you get 18. You add 9, you get 27. You add 9, you get 36, and so on. The multiples of 12, because we're dealing with the 9 and 12, 12, you add 12, you get 24. You add 12, you get 36. You add 12, you get 48. So lowest common multiple of 9 and 12 is 36. There it is. The lowest common multiple is 36. So that in the end, you can take the 2/9. The 2/9, you want to make 9 36. And it's only 4 that multiplies 9 to give us 36. So you multiply the top by 4 and the bottom by 4. 2 by 4 is 8. 9 by 4 is 36. Okay, let us deal with 5/12, which is this other fraction there. You want to make 12 36, you multiply the top by 3 and the bottom by 3. Getting 36 and 15. 8/36 and 15/36. What is 8 plus 15? 23 and 36. Okay, let's continue. So we have made, now the trick here, if you are worked example 1, you're adding fractions with different denominators. You try to make the denominators the same. The denominator was 9, and here it was 12. We made both of them 36, and then you added things up, and then you got 23/36. There's no number that divides into 23 and 36. So 23 divided by 36 is the answer in simplest form. Okay, we're good. So, yeah, so 23 out of 36 cannot be simplified any further. Let's move on. Multiplying fractions. How do you multiply fractions? Like this one, 3 out of 5 multiplied by 10 out of 11. 3 by 10, 15 by 5 by 11. 3 by 10 is 30. So you multiply the numerators and multiply the denominators. Like that. Okay, we're good. So multiply the numerators, but also the denominators. Now look, use common factors to simplify the answer. Okay, so now if we have 30 divided by 55. Let's simplify this one. Okay, this is just basic a little bit. But now, if you simplify this, what do you multiply by? You look for the highest common factor. Highest common factor. So you divide the top by 5, the bottom by 5. 30 divided by 5, it's 6. 55 divided by 5, it's 11. Worked example 2. Calculate 2 out of 3. 2/3 of 12. Calculate 2/3 of 12. So if you say 2/3 of 12 is the same as 2/3 by 12. 2/3 by 12. 3 goes how many times into 12? It goes 4 times. So that 2 by 4 is 8. And you have 1 by 1, which is 1. And therefore 8 divided by 1 gives us 8. So you can be able to get 2/3 of 12 of its multiplication, so that now you just simply divide. Say 3 goes how many times into 12? It goes 4 times, and 4 by 2 is 8, and the answer becomes 8. Okay, some of the tricks you know very well already. Okay, you can divide fractions. 3 out of 4, you divide by 5 out of 7. How do you divide fractions? One of the most popular techniques that we use is to change the order of division for the next fraction. This becomes like 7 out of 5. So you have what? 20. So now this is 21 out of 20. Okay, so we're good. So you can be able to divide fractions, excuse. They are decimals. Decimals. Hundreds. Tens. You need to understand place value when you deal with decimal values. What does 536,247 mean? The digits after the comma represent fractions less than 1 unit, written as tens, hundreds, and thousands. So now if you're dealing with hundreds, for example, hundreds, they're tens, then they're units. All right, so we continue. There are tens, okay? There are tenths. There are hundreds with TH, and there are thousands with THS at the end. So these are the units. And in other words, if you're dealing with the 536, you have the 6 is under units, the 3 is tens, and the 5 is hundreds. Then what about these two after the decimal comma? Right, so it tells you that it's tenths, and then this one is hundreds, and this one is thousands. Right, like thousands. Right, so this is the sort of thing you actually need to take note of. So now 536,247 means that you have 5 times 100. The 30 is 3 times 10. The 6 is 6 times 1. But the tens, like 2 tens would be 2 times 1 out of 10. The hundreds are 4 of them. 4 hundreds, hundreds with TH. So it's 4 times 1 over 100. 7 times the 1,000. 7 times 1 over 1,000. You add everything up. If you add everything up, it is equal to 500. and 36,247. Take a look. Okay, just understanding things we call the place values. Okay. Yeah, most of this is like primary school. Okay, so but we're good. We're just revising. Just going through the document. Okay, now which decimal is bigger? Okay, 0,1 versus 0,01. Which one is bigger? Okay, to see which one is bigger, you can see that in this case, you are dealing with 0,1. And here, you are dealing with 0,01. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so there are 10 rows. 1, 2, 3, 4. Yeah, if we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now this one is like 10 rows, like, yeah, 10 rows and 10 columns. 10 by 10, it is 100. There's 100 squares inside. Well, if you count these little bits, in principle, so there are 100 squares here, but just that this one has just been sandwiched like that. It's just been put together. So now let's check. You then say out of the 100, you actually only take 10 of them. You take 10 out of the 100, the 0 cancels, and you have 1 out of 10. That's why this guy said 1 out of 10, which is 0,1. But now the 1 out of 10 is like you took 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You took like 10 squares. And then you took the 10 squares, and that's what you got. We continue. We check further. Now here you said 1 divided by 100. So we then have, therefore, that out of 100, you took only 1. Right, and therefore you're in a position to then say it's 1 out of 100. So which one is bigger? From the diagrams, we see that 0,1 is bigger than 0,01. Okay, from diagrams, you can see that this one is a bigger part of the diagram and this is much smaller. It's a smaller piece. Similarly, if you are to look at 0,01, it is bigger than 0,001. And 0,001 is bigger than 0,0001. We continue. We continue. Right, and we check more stuff. We check more stuff. Now, for instance, 35,2 is bigger than 35,098. Okay, yes. 2/10. Okay, look at this. It's 2 turns. 2 turns. Because of the 2 after the decimal comma is bigger than no tens. Is bigger than no tens. Clever. So that now if you have 35,2 is bigger than that. Okay. Okay. Rounding decimals. Round off 23,46 to the nearest whole number. Okay. Now let us look at this one. Round down 23 to the nearest whole number. So if you round down 23, you round down 23, round up 24. Let's check this out. So now if you have 23 and then 23, 1, 2, 3, 23,4. And then there's 23,46, which is between 23,4 and 23,5. It's between them. That's where it's sitting, 23,46. So you can round up to 24, right? Which is 23,5, 23,6, 7, 8, 9, and then 24. Let's read what this guy is saying here. Look at the digit to the right of units. Whole numbers in the tens place of 23,46. It is 4, which is less than 5. The halfway point. So we round down to 23. Okay, so example 2. Round 23,46 to the nearest tenth. Look at the digit to the right of the tens. That is in the 100th place of 23,46. It is 6, which is bigger than 5. The halfway point. 5 is the halfway point. So we round up to 23,5. Okay. These things you already know. But now they've just written the stories here. So if you have 23,6, you can round it actually to 23,5. So to the nearest tenth. So the tenth is the digit that sits here. So obviously 6 is going to increase the 4 by 1 unit. Example 3, round 23,5 to the nearest whole number. Whole number. What do? We know very well that this one is approximately 24 because the 5 increases 23 by 1. So it's something you need to take note of. So we continue. Okay, so we're saying 23,5 is half. It's exactly halfway between 23 and 24. By convention, we have a 5. We round up, so the answer will be a 24. Similarly, 23,75 rounded to the nearest tenth will be 23,8. So this one is going to increase 7 by 1, 23,8. Okay. And we're doing this. This is sort of the convention, sort of the rule. We move on. Okay, we're recapping on some of the things here to make sure that your AQL, you just remember some of the basics. Let's look at converting decimals. We can write a decimal as a fraction using our own knowledge of place value. Right, so in other words, if we are given, okay, this is also part of what you need to just in general know, but 0,62, now it's 0,62, what you do, you actually can know very well that it's like this a tenth, right? And dealing with the tenths, and here you're dealing with the hundreds. So that in the end, then you'd have 6 out of 10, 2 out of 100. Now we want to make the denominators the same. 100 denominator. We want to make 10 100. Oh, multiply by 10, 10. Okay. Instead of 10 here, multiply the top by 10, the bottom by 10. Okay, so what is this? 2 out of 100. 6 by 10, it's 60 out of 100. 2 out of 100. 62 out of 100. Okay, this will be like 62 out of 100. So we're changing 0,62 to converting decimals. Right, we can rewrite a decimal as a fraction. We've written this decimal as a fraction. Right, the fraction 62 over 100 can be simplified to You can divide 62 by 2, getting a 31. You divide 100 by 2, you get a 50. A fraction can be written as a decimal by writing it with a denominator of 10, 100, or 1000. So, if we have 1/4, can you write this one as a decimal, and how do we do that? This guy is really convincing us that you can just multiply the top by and the bottom by a number that makes the denominator 100. So we multiply the 1 by 25, multiply the bottom by 25, you get 100. Divide the 2, you get 0.25. But it is difficult to write a fraction with a denominator of 10, 100, or 1000. Then you can convert it using division. Worked example. 1 divided by 8. What is 1 divided by 8? 1 divided by 8 can be written as 1 divided by 8, like we did in grade 1. And now what then can you do precisely? As you said, it is difficult to rewrite a fraction with a denominator of 10, 100, or 1000. Then you can convert it using division. Right, if you find it difficult, you can convert it using division. So now you start by saying you have 1 divided by 8. 8 goes how many times into 1? It goes 0 times. And then obviously, if it goes 0 times, you actually therefore put a decimal comma. And after you've put a decimal comma, you imagine yourself, for instance, with a 1 and a 0, because the remainder is 1. So when you divide 1 by 8, it goes 0 times, but you have the remainder 1. And with the remainder 1, if you look at that, for example, as a 1, 0, what then are you able to exactly achieve? So in other words, you can look at the fact that you're dividing 1 by 8. Let's just do this together. Right, let us remind each other. You divide 1 by 8. How many times does it go? It goes 0 times, but you have remainder 1. Right, and then now if you have remainder 1, for example, and you actually look at the fact that with the remainder 1, even if you perceive that as, for instance, remainder 1, and you add a couple of zeros to it, and you look at that, for instance, as 10, and how many times do you divide there? So if you divide into 10, the remainder is 2, and you put 0. Right. So in other words, you actually continue with the division, and if you divide into 2, it goes how many times? The 8 goes 2 times, and you have remainder 4. You have 0. Right. So you have a set of the remainders here. You had remainder 1, remainder 2, remainder 4, and divided by exactly remainder 4 divided by 8, you have a 5. 0.125. Right, so obviously, it's some of these basics there that you can do. Obviously, I mean, this is when it is a little bit tricky to convert the denominator to 100, to say what number can actually multiply these exactly to 100. So you can play around and actually have this long division method of converting things. And when you put your remainders here, you put your remainders there. Okay, let's move on. Adding and subtracting decimals. Add or subtract decimals in the same way, as we did for whole numbers. Line up the numbers carefully according to the place value. Now, for example, if you have example 1, example 2, 26,000. Okay, or 26. Okay, 26,473. That's what That's what our system of writing is. Okay, we write things strangely a little bit, different from the way the Americans do. For example, if you look at the Americans, we use a decimal comma, they use a decimal point. So it's strange that we write things differently. So example 1 is 26,473, 18,25. Okay, you add the things up in example 1, you get 44,723. But yeah, now you can order them like that. 26,473, and then you put the 18,25. But yeah, you can see we're 1 digit short because this one has 5 digits, and this one would need obviously a little bit. It's 4 digits, so you are 1 digit short. You balance it 0. Let's perform addition. 3 by 0 plus 0, you get a 3. 7 plus 5, you get a 12. 2, then you get a 1. And now, for instance, you have the 1 that is there. And the 1 that is there is going to help us out because it's going to be 1 and 4, which is going to give us a 5 and 2, and which is going to give us a 7. So we continue. We continue. Okay. Right, we continue. Okay, we'll continue. Right. Okay, I'm sorry. Lost. Don't know what happened. Just technology. Okay. Right. So now let's continue. So now you would have, for instance, like the 6 and the 8 gives us a 14. So you bring down a 4 and you carry 1. And the 1 is there and gives you 2 and 1, giving you 3 plus 1, giving us a 4, a 44,723. Example 2. 15,03, then you balance with a 0, and then you're subtracting 2,751. So now, obviously, see, there's a little trick. Now we can borrow as we did for the whole number. So there's a little trick here. And the little trick is that now you're subtracting like 0 minus 1. You have obviously a okay. Let's continue. We need to borrow. Let us deal with this because now, obviously, you're not going to use a calculator in the exam. I'm sure that is why they're reminding you the basics here. So if you have 0 minus 1, 0 minus 1 is a negative 1. And with that in mind, the tendency is to borrow. Right. And if you borrow from these, for instance, you'd actually, therefore, as we did for the whole numbers, if you borrow, the idea is to borrow sort of a unit so that this becomes like a 10, you subtract, you get a 9. But you borrow the units there. So you can imagine yourself, for instance, is having 1 unit less, which is a 2. Right, but now you have a 2 and you run into trouble again because you need to say 2 minus 5. You still have a negative. So you need to borrow. Okay. And when you borrow from this place, you'd be like, how do you borrow from 0? Right. So obviously now you need to realize, hang on. You can borrow from there a unit. You bring it across, giving you exactly. So if you borrow a unit here, you're left with 4. And here you have all right. All right. Okay. Okay, we'll continue. Now, at this point, yeah, we borrow that way. So yeah, if you borrow that way, you have a from the 10, you have a 9, you borrow the 1 and you bring it here. Right? If you have this unit brought here, and then you have obviously 12 minus 5, you have a 7, you have a 9 minus 7, we have a 2, and we have a 4 minus 2 gives us exactly a 2. But now, obviously, you have exactly a 1 here. And then right now, okay, so what exactly do we have here? And a 1 minus 0 gives us a 1. So you can balance here with a 0 if you wish to. Okay, so we're good. Let's continue. Okay, I'm sure they're cultivating the skills, reminding you these skills so that you are able to, deal with the questions. No calculators in the exam for the NBT. Multiplying and dividing decimals by 10, 100, or 1,000. Our system is based on the number 10, so multiplying or dividing by 10, 100, or 1,000 just shifts the place value. Just shifts the place value. Okay, let's continue. Right, each time you multiply by 10, the digits shift up 1 decimal place. Moving the comma 1 place to the right will shift the digits up 1 place. Each time you divide by 10, the digits will shift down by 1 decimal place. Moving the comma 1 place to the left will shift the digits up 1 place. Okay. Let's look at some examples. Now, if you look at 2,03 times 10 is actually 20,3. Okay, so you're multiplying by 10. So you move the decimal place once to the right. 34 divided by 34,12 divided by 10, you move the decimal place 1 place to the left, becoming 3,412. Now, 531,289 times 100. It's 2 places. 2 places. 2 places to the right. Divided by 100 would be 2 places to the left. 1, 2. 5,31289. So we have the following. We have the following. Multiplying decimals. Multiplying decimals. We continue. What is this? Okay, multiplying each decimal by a power of 10 to get rid of the comma. Sometimes we want to remove the comma, and after calculating the answer correct for this and divide by the same power of 10. Let's look at some examples. 0,02, you multiply by 100. So if you take 0,02 multiplied by 100, you remove 2 places, giving us 2. 7,4 multiplied by 10, 1, and it's 74. Okay, now let's deal with this. So now we have 2 times 74, which is okay. Okay. we'll continue. Let's check. 2 times 74, we know it's 148. But if you take 148 and you divide it by 100, which means that if you divide by 10, okay, let's check this. So divide by 100, two places. Dividing 148 by 100 gives us a movement of the decimal point 2 places to the left. But you also you have the following. Right, and then you divide the 100, you divide again by 10. So if you divide by 100, it becomes 1,48, but you divide again by 10, it becomes 0,148. All right. Okay, we'll continue. Let us check. We can summarize what we have done as follows. Multiply 2 times 74, which gives us 148. And so, for example, interesting. And so 0,02 now multiplied by 7,4, what does it give us? So it gives us 0,148. Right. So, yeah, I mean, there are a couple of ways to do this. So you have 0,02. I know you can be able to do that because now you're not going to have a calculator in the exam. So now you move two places. You multiply this one by 100 over 100. We want to multiply 0,02 by 7,4. You have no calculator, remember. So you multiply this one by 100, and then you multiply the 7,4. You must move the decimal point how many places? One place to the side. So now if you want to move it one place, you multiply by 10 out of 10. Multiplying by 100 is going to make this one 2 out of 100, and this one is going to make it 74 out of 100. Meaning that 2 times 74 is going to become 148. And you divide by 100 times, okay, this one is a 10. Right, so it's a 10, this one. 100 times 10 is 1,000. So we move it 1, 2, 3 places. It's going to sit there. So which is 0,148. 0,148. So that is sort of what you're getting. Okay. Next. Dividing decimals. Dividing decimals. First, write the division of decimals as a fraction. First, write the division of decimals as a fraction. Then multiply top and bottom by a power of 10. Choose these to make the denominator a whole number. Example. So 6,51 divided by 3. Right. Okay, y'all. Just a minute. Okay, we're good. Okay, we're good. Okay. Okay, we continue. All right. Now let us look at, for example, Okay, let's do this example. 6,51. Right. Right. So yeah, let's check this out. So you have 6,51 divided by 0,3. So how do we do this? Okay. Now, if the 6,51 divided by 0,3, okay, we wish to deal with what? With this kind of division. So we can deal with 0,3. Right. Okay, now you multiply 0,3 by 10. And then it becomes 3. But you multiply the top and bottom by 10. Okay, because these kinds of things you already know, but yeah, it's just that they're there to lay the foundations because you not have a calculator in the exam. So now, if you multiply 6,51 by 10, you get the decimal point moves one place, and then it becomes 65,1. All right. So first, write the division of decimals as a fraction. Then multiply top and bottom by power of 10. Choose these to make the denominator a whole number. Multiply the numerator and denominator by the same number. We multiplied here the numerator and denominator by the same number to make denominator a whole number. So we made the denominator a whole number. Once the denominator is a whole number, it's easier, much easier, because the denominator is a whole number, then you can divide. How do we do the division? We ask ourselves, how many times does 3 go into 65? Right. How many times does 3 goes into 65? 3 divides 63, going 21 times. And therefore in 65, the remainder is going to be 2. Right. The remainder is going to be 2. And then there is a 0.1. Right. There's going to be 2. And then there's a 0.1. You divide by 3. Now the question is, what is this? This one is easy. You can multiply the top by 10, that by 10, getting exactly a 21 out of, right, getting exactly a, yeah, okay. If this is actually like 2,1 out of 3, multiply the top and bottom by 10. 21 out of 30. So what exactly do we get from 21 out of 30? 3 goes how many times in 21? It goes 7 times. 3 goes 7 times. So it divides here. It goes 7 times in 21, giving us 7 out of 10. 7 out of 10 is 0.7. Okay, we are saying the calculator is not going to be there. So yeah, some of these things are very basic, but you need to just, cultivate the steps. I'm going to ask you some questions to engage your senses. All right, so we're good. We're good. Right, so we're good. Um, we continue, please. Okay, let's check. Next thing. Okay, we must be able to deal with percentages. Let's just remind each other percentages. I know that we know percentages very, very well. Like X percent. What is X percent? X percent is like X divided by 100. What does percent mean? Percent means out of 100. Converting between fractions, decimals, and percentages. Word examples. Convert 25% to a fraction in simplest form. Word examples. Convert 25% to a fraction in simplest form. Okay, let's convert 25%. 25% means 25 out of 100. But 25, so you write percent out of 100. So percent means you divide by 100, and then you simplify. Simplify a fraction, divide top and bottom by common factor. What is the common factor? Common factor is 25. 25 divides 25, giving us a 1. 25 goes into 100 4 times. There it is. There it is. Out of 4 is 1/4. 25%. 25%. So you can look at 25%, 25, 25, or like 25%, 25%, 25%. Okay, it's all 25%, 25%. But now, if we say only 25%, why are we having 4 of them? Well, because 4 of the 25s, they give us 100%. And then now we're going to shade, we shaded only 25%. Means that it's like, it's 1 out of 4 shaded parts. 1 out of 4 shaded parts. We continue. We continue. We continue. Okay, what is the next thing? Okay, these are all basics, you know. You already know all these things. Okay. All right. Convert 0.3 to a percentage. Okay, now how do we convert 0.3 to a percentage? Obviously, the idea is to write 0.3 as a fraction with denominator 100. But now the 0.3 now, first, 0.3 converted to a percentage. I mean, they can ask you these things hoping, yeah, no calculator there. So convert it to a percentage. What do you do? We shall look at the test. Those tests there we have after these. But now, obviously, the thing is to multiply the top and bottom by 10, because you need to move the decimal place once. Multiply by 10 and get a 3, because this decimal place is going to sit here. And then you have that. Okay, 3 out of 10. But for a percentage, we need the denominator to be 100. To multiply by 10, 10, which is 100, and we have 30. But then the decimal point is here, so you move it 1, 2 places, and that is 0. Okay, so in other words, anyway, you might decide not to move it. You might leave it exactly as it is. Why? Because now you're good. Because 30 divided by 100 is 30 per 100 and is already 30%. So yeah, we're good. Let's write it as a percentage. Okay, reviewing this particular document here. Okay, we're good. We're good. Okay. Now let's look at the next one. Calculating a percentage of an amount. To calculate X% of an amount, use X% of the amount. 20% of that. Right, so 20% of 75 is like 20% times 75 Rand. Okay, good. What is 20%? It's 20 over 100. 75. So yeah, we're good. We want to get the answer here with ease. You can see what this guy is doing. This guy is saying, okay, watch out. 20 goes 5 times into 100, but it goes once into itself. But 20 goes 5 times into 100, and this gives us 1 by 75. It is 75 divided by the 5. If you divide 75 by 5, you get 15. This is the answer. The answer. Next. Finding what percentage a part of a whole is. Okay, now they can ask you some little questions like this, hoping that you have no calculator. To find what percentage a part X is of a whole Y, we want the fraction. Okay, And let's read this carefully. To find what percentage a part X is of a whole Y, we want the fraction X of a Y of 100%. Worked example. There are 21 learners out of 420 learners in a school, or rather 21 learners out of 420 learners in a school sing in the choir. What percentage of the learners sings in the choir? Yeah, so we have 21 learners are singing in the choir out of 120 of 100%. Okay. 21 out of 120 sing in the choir. What percentage of the learners sings in the choir? Okay, anyhow. Okay, language terms there. But now, we have the following. So what exactly is the answer to these? So you can see this guy is really saying, okay, take a look at the fact that 21 is able to go into 420. It goes 20 times, but it goes once into itself. So that you can have, we shall have 1 out of 20 this way. And the 100 by 1, you can put the 100 this way and then put the percentage outside. 20 goes how many times into 100? It goes 5 times, which means we have exactly 5%. So just some basics, because now they're going to ask you 21 learners out of 420. What is the percentage of the learners that sing in the choir? It's 5%. Okay. We're good. Okay, there are certain things like calculating percentage increase or decrease. This can be tricky. This can be tricky. You find this one also in many other applications, like in life sciences. I've seen this a lot. And you can even find in the physical sciences. Of course, in mathematics, it is part of it. How do you find the percentage increase or percentage decrease? There's a formula that you must just remember. Right, and yeah, it helps to remember the formula. To find the percentage by which something has increased or decreased, we calculate the following. Now, if you check very carefully, okay, now we have the following. New amount minus original amount divided by original amount. Okay, this is the formula. The new amount minus the original amount divided by the original amount times 100%. Let's look at a worked out example. The number of learners taking maths drops from 500 to 470. What percentage of the learners drop maths? Okay. So now you then say the percentage decrease is the new amount. And the new amount is dropped from 500 to 470. So the percentage decrease is going to be the new amount of 470 minus the original amount of 500 divided by the original amount of 500. You multiply by 100 so that you have a negative. The negative shows that this is a decrease in percentage. So it is a percentage decrease. So you must remember how to do your percentage decrease, because yeah, they're gonna trick you in the questions. In the tests, we shall check more of this. What about increase or decrease by percentage? To increase an amount by X%, you need or you add X% of the amount to the amount. Let's check this out. Amount plus X% of amount, which is amount plus, what is X%? X% is like X of 100 of the amount. it's equal to amount, it's a common factor. You take out amount, and then now you have x over 100 and then 1. We're good. Let's look at the decrease. To decrease an amount by x%. Okay, so here you would have increased it by x%, because if you increase by x%, you take the amount and you add x% of the amount. Then you are increasing the amount by adding x% of the amount. So in other words, you are increasing an amount by x%. To decrease an amount by x%, we have the amount we decrease by x%, which is the amount minus x over 100%, which is the same as x minus 1, because the amount is a common factor. So you have 1 minus x over 100. The amount is a common factor. We look at the worked examples. The price of milk. Okay, the price of milk was 11 rand, but it increased by 5%. What is the new price of milk? Now, to get the new price, we're going to say it was 11 rand before, and then it increased by 5%. So we add 5% of 11 rand. 11 rand plus x over, right, yeah, 11 rand plus the 5% is 5 over 100 times 11. The 11 rand, we take it out, and we have 1 plus x over 100. And then this is the same as what? Right, if you add 1 plus 5 out of 100, okay, it's the same as multiplying 10, this 100 by 1, getting 100 and the 5, which is 105. In 105, you move the decimal point. 105, you move the decimal place by some 105 divided by 100. So you move 1,05 times 100, and therefore you have exactly this. You have exactly that there. Yeah, the couple of ways to do this, and because now if you say 105, divide by 100, you can then take the 11 rand, multiply the top and top, 105 times 11, then you have whatever you get. You divide by 100, you move the decimal place to this. I know you can do that one. Can actually be in a position to do that one. For example, now you can have for example, 105 times 100. Times 11 rand, excuse me. So what would you do here? There are a couple of ways to do this. One way is to multiply the 11 by 105, but you can look at the 105 as 100 plus 5. You multiply here. So it's 11 rand times 100. You have 11 and 2 zeros, 55 rand, which is 11.55. Okay, you take the 11.55, but now if you take the 11.55, you divide by what? You divide by, there's 100 there. How many decimal places? 1, 2. Giving us exactly 11.55. 11 rand 55. We're good. Okay, we're good. Next, you get a discount of 25% on a shirt. Okay, you want to buy a shirt and you get a discount of 25% on a shirt. That costs 400 rand. How much do you pay for the shirt? The new price of the shirt, because you got a discount of 400. So you then say 400 minus 25% of the 400. 400 minus 25 of 100 of the 400. The 400 is a common factor, so you can take out the 100 as a 400 as a common factor, and you have 1 minus 25 out of 100, which is 1 divided, which is 0.75 times 400, which is actually exactly 300. Exactly 300. We continue. There's something we call the percentage back to whole. You might need to change the percentage back to whole. Like if X percent is an amount, then 1% is what? 1% is the amount divided by X. Yeah. It's very, very obvious. So if you take X percent is actually equal to an amount, you divide by X to get 1%. So that X over X is 1. You get 1% and you have an amount divided by X. Okay. What about 100%? So you multiply the left by 100 and the right by 100 and you get that exactly. Okay. We continue. We continue. Let's check. So we said that with the X percent, you divide X by X, you get 1. And therefore it will be whatever you do on the left must be done on the right. So you divide also the amount by X. We're good. But now we want to get 100%. So you multiply the right by the amount 100 and also the other side by 100 and you get 100%. You have 100. Worked example. 30% of my class is boys. So the boys form like 30% in the class. There are 12 boys in my class. How big is my class? Okay, here is an example. How big is the class? So they're going to ask you questions like that. Let's check. Yes, it ends at half past. Thank you so much. It ends at half past. I'm able to see that. It half past because we lost time. So yeah, we're gonna end at 12:30. We lost time. We lost time. You know, there was a glitch a little bit, so it's gonna be half past. Thank you so much for noting that. I'm aware. I'm seeing the time. Right, worked example. So we're saying 30% of my class is boys. There are 12 boys in my class. How big is my class? So we have 30%, which is 12 learners. 30% equals 12 learners. Because in other words, the 30% of my class is boys, and that means that 30% equals the 12 learners, which are the 12 boys. But now you have 1%. So you divide by 30. So that 1% is 12 out of 30. Multiply by 100 both sides, meaning 100% equals 12 out of 30 times 100. 40 learners. So there are 40 learners in the class. Beautiful, beautiful method. We move on. Let's look at ratio and rate. What is a ratio? A ratio compares two quantities of the same kind, that is, people, cups, kilometers. So a ratio compares two quantities of the same kind. We compare people, cups, and kilometers, etc. An example, in a recipe, I use 3 cups of milk for every 2 cups of flour. This tells us the ratio of milk to flour. The ratio of milk to flour. We can write the ratio in different ways. The ratio of milk to flour. Okay, so you have 3 to 2. 3 to 2. 3 out of 2. So we continue. These are just ratios. Let's continue and look at the rates also. Equivalent ratios. Sometimes the ratios are equivalent. Ratios can be written as fractions. Equivalent ratios are equal, but the numerators but the numbers in the top and bottom of the fractions are different. To find equivalent ratios, we can multiply or divide each number in the ratio by the same amount. We continue as follows. An example, the ratios 12 out of 16, 3 out of 4, and 15 out of 20 are equivalent. 12, the ratio of 12 to 16, 3 to 4, 15 to 20 are equivalent. How do you see that? We divide, whenever we divide 12 by 4, we get 3. But also, if you divide the top by 4, you divide 16 by 4, which is the bottom, you get a 4. Okay, now you want to move from 3 to 15, multiply by 5, you get 15, multiply by 5, you get 20. So we continue. Worked example. At a camp, there is a ratio of children to adults, 5:2. If there are 30 children at the camp, how many adults are there? So we agreed that at the camp, there is a ratio of children to adults, 5:2. If there are 30 children, how many adults are there? Right, so the adults, we call them a question mark, and therefore the number of the adults would be, so in the same way now we can see if there are 30 children, so in other words, it means that the 5 was multiplied by 6. You must multiply 2 by 6 to get a given number here. And so now if you then say 2 by 6, what do you get? You get exactly 12, and therefore we are able to deal with the part ratios. Okay, let's look at what we call the part to whole ratios. Part to whole ratios. We dealt with the part to part. A worked example. At a camp, there is a 5:2 ratio of children to adults. At a camp, there's a 5:2 ratio of children to adults. If there are 140 people at the camp altogether, how many children and how many adults are there? We know that for any 5 children, there are 2 adults. For any 5 children, there are 2 adults. So there are 5 children in every group of 5 plus 2, which is 7 people. So the children to people would be, right, so the children to people will be 5:7. So with the children to people now, you then say, okay, if really here we then say the people are 7, the children are 5. Right, if you have 140 people, if there are 140 people, it means therefore it's only the number 20 that multiplies 7 to give us 140. And therefore, you multiply by 20 on the right, you multiply by 20 on the left, and 5 by 20 would give us 100. The number of adults would actually be the same as 140. 140 is the total number of the people, right, minus the number of the children. Because now we say the total number of the people is 140, but the children are 100. So we remove the children from all the people, and we have 140 minus 100. We get 40 adults. We continue. We have 9 minutes. We're looking at ratios, but now let's discuss rates. Let's discuss rates. A rate is similar to a ratio, right? So we note that a rate is similar to a ratio, but now we're able to see that if a rate is similar to a ratio, but a rate compares two different kinds of quantities. Now, we note similarities between ratios and rates, but a rate compares two different kinds of quantities. Okay, now you see, many times somebody can ask, and learners can ask, what is the difference between a rate and a ratio? A rate is similar to a ratio, but a rate compares two different kinds of quantities. Example, a car can travel 26 kilometers on 2 liters of petrol. How far will it travel on 6 liters of petrol? At this point, you have 26 kilometers. 26 kilometers to 2 liters of petrol. How far will it travel on 6 liters of petrol? Now we have 6 liters of petrol, and then how far will it travel? And the 4, you then say is 2 liters. You multiply by the 6 liters here, so it is 3 times 2, or 2 by 3, which gives us 6 liters. You multiply by 3 on the right, you multiply by 3 on the left. 26 by 3 would give us what? 26 by 3 is 78 kilometers. The distance the car can travel will be 78 kilometers. We're good. Okay, we continue discussing rates. Let us discuss the notion of using unit ratios and rates. Sometimes it is not easy to see what number to multiply by to get the equivalent ratio we want. It helps to find a unit ratio or rate, a ratio or rate with one in it first, and then get the ratio we want. Work the example. A factory, okay, these are the kinds of examples, these are the kinds of problems you're going to find. A factory produces 261 boxes in 3 hours. If the factory produces boxes at that rate, how long will it take to make 870 boxes? So we have the following. It is not easy to see what we've multiplied by, so we'll first make a ratio with a 1-to-1. Because in the end, what then if the factory, remember, a factory produces 261 boxes in 3 hours. So 261 boxes are to 3 hours. But if the factory produces boxes at that rate, how long will it take? How long will it take them to actually make 870 boxes? How long? 870 boxes, we need the time. So now we have these kinds of ratios. The time taken to make 1 box. How much time is needed to make 1 box? So time to make 1 box would be 1 box is to 3 divided by 261. 3 divided by 261. So this is the time taken to make 1 box. The time taken to make 870 boxes. So you can multiply by 870 here, 870 there. So 870 boxes will be made in 3 out of 261 hours times 870 hours. And therefore, so it will take 3 divided by 261 by 870, and this is exactly 10 hours. Be good. Next. Okay, we're gonna play around with some of these things. We're gonna make time during the course of the week to practice this more. All right, we need to practice this more. Like throw in some pop quizzes on this and discuss and see the tricks. Okay, there are some little tricks here that really can throw you off. There's something we call direct but also indirect proportion. This is like physics. What is direct proportion? 2 quantities are directly proportional if they have the same constant quotient. The answer when you divide. All right, so you continue. Let's look at a worked example. Distance. The distance is what? If the distance is 60, 120, 180, 210, 240. Those are the distances. Like 60, 120, you increase by 60. The hours are 1, 2, 3. 3,5, then 4. Distance divided by time gives the constant speed of 60 kilometers per hour. Let's check. Distance divided by time. If you look at the distance divided by time, you divide 60 by 1, distance divided by time, you get 60. 120 divided by 2, it's 60. 180 divided by 3, it's 60. 210 divided by 3,5, it's 60. 240 divided by 4, it's 60. Okay. The distance traveled increases in direct proportion to the time. As the time increases, the distance also increases. This is very important. As the time increases, the distance also increases. So the distance traveled increases in direct proportion to the time. Right. The distance was 60, the time was 1. The distance doubled to 120, the time also increased to 2. The distance now increased to 180, the time became 3 hours from 2 hours. So we can see that indeed it is true that the distance traveled increases in direct proportion to the time. Direct proportion to the time. So what does direct proportion mean? It means when one increases, the other increases as well. So as time increases, the distance also increases. We're finishing, please. Few minutes. There's something we call the indirect proportion. Indirect, what we call the inverse proportion. Two quantities are indirectly or inversely proportional if they have a constant product. Constant product. The answer when you multiply. Let's look at the weight example. It takes 24 days. Okay, because these are the kinds of exercises you're gonna meet in the exam, right? It takes 24 days for one worker to paint a factory. So 24 days you paint a factory, but one worker only. The table shows the number of days it takes depending on how many workers are employed. Okay. Number of days. Now, the number of days are like 24 days, 12 days, 8 days, 4 days. 24 days, number of workers, 1. The table shows the number of days it takes depending on how many workers are employed. So now, in other words, the number of days, if there are 24 days, number of workers, only 1 worker. This worker can paint a factory. But now, if there are to be, the factory must be painted in 12 days, you need 2 workers. The factory must be painted in 8 days, you need 3 workers. The factory must be painted in 4 days, you need 6 workers. Okay, if they're to paint this factory in like 2 days, you need 12 workers altogether. So that in the air, we can see 24 by 1 is the same as 12 by 2, 8 by 3, 4 by 6, 2 by 12. 24. Number of days, time, number of workers is constant. Take a look. Okay, now, right, the number of days to paint the factory decreases as the number of workers employed increases. Number of days to paint the factory decreases as the number of workers employed increases. If the number of workers increases and there are more workers, the number of the days become fewer. The more workers there are who are working together, then it means the days are fewer. They do their work quickly because there are many. So the number of days right, and number of workers are indirectly proportional to each other. Right, I think that our time is up. Thanks so much for joining us, Newar. It was awesome having this discussion. Right, as said already, we have Saturday as our meeting time, but we shall make more time available during the week. I will obviously contact you there.